Hello, hello. All right. Cool. Thank you. Hi everyone. I'm Anirudh. I'm conducting a workshop today on how to build your own AI agents with Eliza OS and Gelato Web3 services. So Eliza OS is pretty much the new framework. It's the new operating system for building AI agents, and I've combined this with Gelato Web3 services, mainly the Gelato Relay, the Gelato Web3 functions, and lastly the VRF. And I've pretty much built like a demo as well to showcase everything and how it comes into play, which I'll be showing you at the end with the cool demo. But yeah, really excited to showcase to you guys. Quick outline, my name is Anirudh. In this demo, in this workshop, we'll be covering what the Eliza OS framework is, what the Gelato Web3 services are in general, and what exactly is this CoinFlip AI, which is the demo that I've built, and how CoinFlip AI makes use of Eliza OS framework with the Web3 services. So I'll be diving deep into the architecture as well. And lastly, I'll showcase the live demo as well, towards the end. So that's like a quick outline. Cool. So how many of you over here are aware about AI agents? Or that's a word that you've heard so far on Twitter. Can I get a quick show of hands, please, if you have heard what AI agents are, what they do? Perfect. So I think you all know what they are. But given that you don't know, I'm assuming just for the sake. So AI agents are pretty much self-operating systems. Agents basically they don't really need much human intervention. They can just perform tasks much without human intervention, and they can pretty much understand and respond to things without having to take much actions, and they'll pretty much take actions to achieve their goals. And the most important thing is that after they have taken actions, they'll actually be able to learn from those actions and actually iterate over and make them even better. So that's pretty much like a gist of what AI agents are in general. Right. So in this demo, I have used Eliza OS, which is the operating system for AI agents, and it's the multi-simulation framework for autonomous AI agents, and pretty much it's written in TypeScript and it's fully open source. You can check out the code as well on GitHub. It's Eliza OS/Eliza, and it's developed by AI16Z actually, which is an AI-driven DAO. And pretty much what you can do with this is that you can actually design custom AI personalities with memory and decision making, and you'll also get a cool runtime as well, which will allow you to customize things in general and build it to your own use case. So that's Eliza OS, introduced very, very briefly, but I'll also be explaining about the architecture itself. So over here you can see that the main thing over here is the AI agent runtime, which consists of the LNM, the memory, as well as the plugins. And you can actually inject some sort of character config file, which is cool because you can actually give it some sort of definition to like, hey, I want it to act like, let's say, like Donald Trump, for example. I want it to act like, some Andrew Tate, for example, right? So you can pretty much give it like your own personality as well. And you can have your own databases. You can inject it with database adapters. You can link it with that. And lastly, you have the client, which is also what it does towards the end as well. So to sum it up, actually this is the architecture I took from the official Eliza docs. This is from the version 0.25.9. The interesting thing is that Eliza will be releasing a new version as well. It's called V2. It's still in the works, but yeah, I built a demo using this version, so I'm just going to be explaining about this, but maybe later down the line I can update it. But yeah, like I mentioned, so the first thing you have the plugins, which is this part over here. So plugins are the packages or anything in general that will help you expand the capabilities of your agents. And these are pretty much already there in the repo. You just got to use them. Like NPM packages, for example. I think you can think of plugins like those. The character file, these are just JSON files, right, where you can define your AI agents and the personas as well. Then you have the database adapters where you want to store all your data and for your agent itself. And lastly is the client where your agent will actually interact at the external platform, right? So that's what it is. But yeah, if you like to learn more about the agents, I've attached the docs as well. you can go to eliza.how. You can take a look at the V1 beta docs. I think they'll be updating to V2 as well. And you can just pretty much understand about all the core components there in general. Right. So now that this we have understood about Eliza OS, let's take a look at Gelato Web3 services. So Gelato Web3 services consist of Relay, Web3 functions, and VRF. So these are the top three. Relay is the solution for gasless transactions. Mainly, is being used for with customers like Infinix, for example, Courtyard, for example. They use it for sponsoring transactions on their platform. And yeah, it's super easy to implement. And it will scale, and we support multiple networks as well. And what you essentially do is that in order for you to pretty much implement this gasless relay in general, you first, as a developer, you have to identify what's the gas sponsorship approach that you would like to take, right? So this could either be an on-chain payment, or this could either be an off-chain payment. So for on-chain payment, the users can pay gas with native or ERC20 tokens, right? And for off-chain payments, this can be sponsored partially or fully with the gas tank, which we have on Polygon is called the one balance. And the next step towards implementing Relay would be to selecting your SDK method. Now, what does that mean? So pretty much, since there's the on-chain payment and there's the off-chain payment, the on-chain payments has two categories as well, which is the call with sync fee ERC2771. Now, what exactly is ERC2771? That's the meta transactions that's being supported. So with this, you'll be actually able to decode the original message.sender in your target contract. And then we have the call with sync fee. And then for sponsored call ERC2771, that's the method that supports meta transaction and the EIP712 signatures. And we have the sponsored call method for the regular calls as well. And lastly, for Relay, you just actually deploy your contract with the inherited contracts that you have. You integrate the SDK into your front end or your back end, and you just launch. And you just pretty much have this transaction where you can actually gaslessly sponsor transaction for your users or onboard, help them onboard, right? So that's Relay. Right. So that's Relay. Now for functions, it's the leading smart contract automation tool. It's being used by customers like Austrian, for example, right? And we pretty much what you do is that you can actually use you can actually use off-chain data and have it automate based on that. So you can react to on and off-chain events. You can actually access the off-chain data using external APIs, and it's also available on multiple networks as well. And pretty much what you do is that there's also like three major steps given that you want to implement this in your app. So firstly, you would select your trigger. This could either be a time-based interval. This could either be a cron expression, a block, or on-chain event. And based on this, you can actually select either what you want to run a TypeScript function, either you want to run a Solidity function, or either want to run an automated transaction, right? So once you have identified those, you'll actually deploy the TypeScript function, or you'll actually work on writing a Solidity contract, which will help you with the automation. And lastly, you deploy these contracts or the IPFS code, and you pretty much run the task, top up your one balance, which is the gas tank, and your task is up and running. And this one balance, which is the gas tank, will pay for transactions on all the networks, right? And this is supported across all the middleware services that are available on the app itself. So that's Web3 functions in general. I'll actually be showcasing this to you as well on how this has been used in the demo and the UI as well, just so you have a better understanding on how it looks in general. And yeah, lastly, we have the verifiable on-demand randomness, which is called the Gelato VRF. And yeah, it's pretty much being used by customers like Sofamon, for example, or YOLO Games, LooksRare, right? And yeah, they mainly use it for let's say for the NFT mints, or for GambleFi is also one of the main use cases. And yeah, It's also compatible with Chainlink VRF, which will save you 16% on cost, and also available on multiple networks. And it's also pretty easy to implement this. So it's a three-step process similar to what we have for Relay and VRF. You pretty much inherit one of the consumer-based contracts which you have. You fund and you pretty much you top up your one balance and spin up your Gelato VRF task with your consumer contract. And yeah, you just launch your VRF instance, and that will pretty much deliver randomness every time a request randomness event is emitted. So that's how that works in general. And that's like the summary of all the middleware services of Gelato. And all of these three are being used in this on-chain AI agent demo that I'll be showcasing you a couple minutes down the line. Cool. So now that we have understood what ELIZA OS is, its architecture as well, very, very briefly, and we have understood what the Gelato middleware services are, I would like to explain and also showcase to you the plugin Gelato, which is one of the plugins that's officially supported in the ELIZA OS GitHub repo. You can check it out at the GitHub link as well, which is ELIZA OS plugin/plugin Gelato. And pretty much what this plugin will enable you to do is that it will enable your agents, let's say. So in your case, that's going to be your agent that's going to be making transactions. And this will allow your agent to gaslessly send transactions for your users or for the agent itself, right, onto any EVM-compatible blockchain using Gelato Relay. And for this, I've made use of sponsored call and sponsored call ERC2771. And the reason was because obviously it's easier for me to maintain this one balance on just one address, and it just takes care of the transactions on all the supported networks. But, and how this generally works is that you have this, you give it some prompts, right? And you give it all the necessary details, and it will actually figure out if to make a sponsored call ERC2771 or a regular sponsored call. And this makes it easy for your users or for your agent to interact with the blockchain to, using a ChatGPT-like interface. So that's the reason why I initially built this plugin, is so that users don't really have to configure their wallet address and interact with they can just do it gaslessly without having to worry about holding native tokens in general in their wallet address. So how do you implement this plugin Gelato for yourself? Given that you're working with ELIZA OS, I mean, the main things that's available for you are the interfaces, which you can use. So pretty much you have to build on top of this interface over here, and you have to implement your logic for your agent. So you're going to be working a level over here. So you're going to be working over here. You implement your logic, and you pretty much implement the contract interaction interfaces, and that will then decide whether to use sponsored call or sponsored call ERC2771. So yeah, like I mentioned, why one balance? So yeah, basically just the need for maintaining a balance on just this one address on Polygon, and making it easy for me to track and pay for transactions on all the networks. Cool. So that's pretty much like an introduction to everything I'm going to be showcasing you now. And pretty much what we have built is CoinFlip AI. Then we call this in the demo called CoinFlip AI. And this is pretty much an AI-driven betting game where players will place bets, and the AI agent can decide the winner through a fair coin flip using Gelato VRF under the hood. I'll also be explaining you the architecture for this as well. And the game is fully decentralized because we're using Web3 functions for automation, and we're using VRF for getting the output of the result. And we're also using Gelato Relay from the agent itself to send out transactions to the target contract, which is the contract deployed, in this case, on Ink Sepolia. Right, so this is so basically, like I mentioned, right, in the ELIZA OS repo itself, when you create plugins, you pretty much implement actions as well. And with this, like I mentioned, you build on top, right? So if you see over here, you implement your logic here, And this is the logic that I've implemented on top of the plugin Gelato. And what this does is that this will provide a user-friendly interface for the game-related actions, right? So you can actually check the results of the game, you can place bets, you can read the information about the round itself. And the game logic is pretty simple. So it will first read the balance of the wallet address. Does it have enough balance to play the game? If so, then it will just place the bet. And it can also pick a random bet as well. So that's like basically like the summary of the action that's being written on top of plugin Gelato for the game and the demo. And yeah, this is the actual contract interaction interface that I've used. And this will allow your agent to interact with any smart contract. And it expects a prompt containing the correct ABI function name. Pretty much it will construct this object so that it can actually send out the request to the target contract using VM using VM to the target contract. Right, so I can show you an example of placing a bet over here. So pretty much is decoded, and it can be done in 3 steps as well. So step 1 is to use LLM to get the user input. So let's say if a user inputs, place a bet for me, right? You can actually use the ELIZA OS handler from the runtime to actually extract this info and decode it. And based on that, the logic will then follow. All right, once you have placed a bet, based on that, check the user's balance, then create the contract interaction action object from the function, and that parameter will then be passed to the smart contract on a desired chain. This is how it looks like. This is just a sample code. So yeah, you can see that the action, you create an object, and in the response, you can interact with the contract. I call my contract conflip VRF ABI. And yeah, you can pass all these input parameters. And given that I'm passing the user address as well, this is going to be a sponsored call, ERC2771 call, so that can be decoded in the target contract, and we know which user is actually calling the bet function. Right, so something about the game itself. How does it work? So you have the players that join join and place bets. So pretty much you're supposed to, I mean, at least for the sake of this demo, you run this agent locally. You spin this up, you run this locally. And player can actually interact with the AI assistant chat, the ChatGPT-like interface. And the game will wait for the next round, and it will be in fixed intervals. So every minute, the round will be coordinated by Gelato Web3 functions. And all the bets that are placed before that round, it will be included for that specific round. And Gelato VRF will flip the coin for every round. And once the timer reaches 0, or every 1 minute, the round is locked, and it will then be provable by Gelato VRF to the target contract, and the round is then resolved. And then the winners are decided on who won, who lost, and the players can ask the AI assistant on who won, and they get the result. So this is like a very an architecture of what's being built. So even you can actually spin up. So you can have multiple players spin this up, connected to the backend server, which actually helps in a bit of coordination as well. But mainly, if you see, you have the chat UI and the agent, and each player can spin this up locally. And whenever they place bets, they can actually relay this transaction to the CoinFlip VRF contract. And yeah, every minute, Gelato will then scan for events, and it will find out all the users that have placed their bets. And it will then request round for randomness, which will then emit an event called request randomness. And this is then fulfilled by Gelato VRF, and then the round is resolved. So that's like the flow. So you start off over here, you relay the transaction. Gelato functions will then pretty much, every minute resolve. Sorry, not resolve. It will actually find all the players that have placed the bets. It will then ask Gelato VRF for the randomness every minute. It will then fulfill the event, the randomness in the target contract, and you get the resolved round. Right, so this is like some screenshots from the AI agent itself. So here's the thing. So this is from the personality as well. So here you can see like, hey, can you explain me about yourself and what do you do? So with this character config, you can actually see that I've managed to have it, in a way that it only talks about the game itself, like the game master. So in this case, I've called it the flip master, and so flip master is basically responding like, hey, I'm a flip master, your dedicated AI assistant, and I'll be helping you place bets, track order. And this is what actually the character JSON file actually does initially. And that's like, these are just like a few screenshots. So yeah, I said like place a bet for me with 0.01 ETH on tails. And yeah, it actually went ahead and placed the bet. And yeah, you can see that the transaction was relayed using Gelato relay. And the bet was placed with the choice of tails. And yeah, lastly, I asked, did I win? For this specific screenshot, not really. But yeah, you can actually win as well because it's obviously the result will either be 0 or 1, which is heads or tails. But yeah, that's how the game actually works in general. So yeah, now that we have actually covered what the game exactly is and how it works, we can proceed with the demo. And with that, you have to have the Node version 23.3.0, the PNPM or Yarn, for example, whatever you prefer. And you got to have a env file with your wallet key, with your Gelato Relay API key, and something optional would be to have an open API key. But if you want to use your own LLM locally as well, then that's completely fine. That's something you can configure in the agent itself. Cool, so I'll proceed with the demo. Before I proceed, yeah, so pretty much everything is open sourced. You can check out the repo over here as well. Yeah, the entire code, you can actually just clone it and just run it yourself. It's pretty straightforward. I'll be showcasing this to you as well. But before we jump into that, I would like to showcase you the event processing and the detection from Gelato Web3 functions. So this is how that looks. So as you can see that it's being run using a time interval, and it's running every 1 minute. And yeah, it's using a TypeScript function, which is deployed on an IPFS at this IPFS code, a CID, sorry. And you can check out my code as well over here. It has all the ABIs and the logic for pretty much working with this game. And you can actually see the executions and whatnot over here. So pretty much, it's a full suite of monitoring that you can have, and you can check the task logs as well. So currently, there are no bets placed in the last 60 blocks, but yeah, that's going to change because we're going to be placing some bets. And we have the VRF round resolution as well, which is over here. And this is the VRF task that will actually deliver the randomness to the target contract, which is over here. Let me just showcase this to you. And let me walk you through over this target contract as well, which is deployed on Inkspolia. So I'll just walk you over the basic read-write functions over here. So yeah, basically you can read the current round. The current round is 12. You can check for ETH balances. You can check for the owners. You can check for the round, the VRF operator. And you can pretty much deposit fulfill randomness. That's only to be done by Gelato VRF task. You can place bets. You can request randomness. That's to be done by the Web3 function. And yeah, that's pretty much like the gist of the smart contract for this demo. Now, what's to be done is that you'll actually clone this repo, and I'll actually showcase you. And it should initially look like this, right? And pretty much you can actually, let me just close everything over here so it's much more readable. Right, so initially your project will look like this. And everything that you have to know about the plugin itself, you can find it under packages. And you can look for plugin Gelato, which is which is right over here. And you can see that there are 3 actions, and like I mentioned, you're supposed to build on top of the contract interaction, so it looks like, so for me, it's this logic right over here. And as you can see, I'm importing the contract interaction, and then towards the end, I'm pretty much, I have this logic over here where I get the response, and I just try to decode and try to, you know, send requests to the target contract. So everything about the logic that you have to know is over here. So things like, you know, placing bets, things like did I win the round, things like place a bet for me randomly, right? So all of this is going to be over here in this action user friendly. And yeah, and about the logic itself for the TypeScript function for execute sponsored call, that's going to be in action contract interaction. And pretty much you can create a contract interaction object, and you can then execute sponsored call. But you don't really have to worry about that, but you can just take a look. And yeah, that's pretty much like the action. You can actually explain and give it some examples as well. If you have not used ELIZA OS before, you can, you know, explain it like, hey, deposit 0.1 ETH, for example, right? And this will, all right, deposit 0.1 ETH. So this is just for the context and for the understanding of the agent itself. So you can pretty much train it how you would like this to be used. So that's some walkthrough about the plugin and about ELIZA OS in general, right? So I'll just clear this up, and I'll just go to the root, right? So once you enter this, once you fork this, you're going to be on the update Gelato plugin branch, and you just quickly run a pnpm install to quickly install the things. I've done that already, but I think this might take quite a while, given that if you install it for the first time, just because of a lot of packages. But yeah, I think in the next version, in the next iteration, maybe can make this more optimized as well and get rid of all the things that are not being used. But yeah, pnpm install, and then you can run a pnpm run build. Yep. And then this will quickly build all the packages that are available. And yeah, so now you have built everything, and you can go to agents as well. Now, why do you go to agents? And that's because if you check the agent, and if you go to source, and if you go to index, this is where all the main logic is for running all the plugins, running everything about the runtime in general. So whenever you start your server, you're going to be starting it off from the agent repo, the agent folder. So yeah, you go to agent, you have to run the install over here as well. And yeah, this might take a while depending on when you're running it. Since I've already have it locally and I have it saved, it's fairly quick. And I can actually now start the server. And this should spin up a server for the agent itself. And this should also take a couple minutes for it to spin up. So yeah, while this is loading up, you'll actually get an option at the end to get a chat UI. This is just something that comes out of the box with the ELIZA OS framework, but you don't necessarily have to use it for your use case, right? You can actually just use the backend server and have it interact, via your own front end. But I just decided to use the front end out of the box over here. You can read more about the API itself. It's going to be somewhere in the actually forgot, but I think it's one of the clients over here. Let me just quickly check. I think it's called Client Direct or Client. It's one of the clients over here. I might give some more information about this, but you can actually find the information about the API itself from the backend to the front end and how it interacts. So now that we have the backend spin up, the server itself, and then now we can run a pnpm run start client. And yeah, so that has spun up a server at localhost 5173. Let me just use this. Cool. So this is what it looks like. You can actually have multiple agents running as well. In my case, I'm just running the coin flip player agent, but you can, like let's say for your personal use case, for example, you can have like coin flip, you can have like, some own random agents running for you as well. And then you can chat with them. This is how the chat UI looks like initially when you spin it up. So you can chat, and you can be like, hey, like I'm going to use the same example from the slide over here. It's like, hey, can you explain me about yourself? And this should pretty much give me the answer about flip master, it being a flip master. I can actually show you the configuration that I've used as well for defining this character config. So as you can see, it says like, hi, I'm flip master, your companion for coin flip. And what you can do, and to showcase you the example of the character config as well, let me just find it quickly. It's gonna be in agent, it's gonna be in source. Yep. So this is how the character looks like. So this, you define it using the character, and you can pretty much give it explanation as to what plugin it has to use, what the system prompt is, what's its knowledge, and you can give it some examples as well, like, hey, what's my balance, right? And this will pretty much allow you to customize it to your use case. In this case, it's just going to be placing bets. Right, so now that's done. I think we can go ahead and place the bets. Like I mentioned, that the contract is on Ink Sepolia, and you can just do, like place a bet. I'm going to use the same example. Place a bet with 0.01 ETH. Actually, let's go with 0.001. So it's 0.001 ETH on, let's say, let's go with heads, right? And this will then actually trigger a relay transaction. Hopefully, this should send out a task ID. Whoops. Getting an error. Let me quickly check. Sponsored. This is the live demos. Let me just quickly check. Unknown sponsor API key. Let me just try again with the different prompt. Let's see. It's still gonna give the unknown API. All right, that's sure. But I do have a video of me placing the bets. Maybe I can just quickly showcase, since the. Let me just quickly find it. But yeah, ideally it should look like the it should look like that in the demo which I've showcased. It should look like this. It will show bet placed, and pretty much you will be able to see a request in the Web3 function, which will then actually find all the events of the users that are placed, and this will then be read in the internal transactions of the actual smart contract. As you can see, I just did a couple days ago, and I tried it this morning as well. It worked, but I don't know why I just decided to fail away. But yeah, that's how the transactions will come in using Relay, and then the VRF will actually go ahead and fulfill all these transactions to your target contract. And yeah, that's pretty much like the demo. We do have a YouTube video as well, which you can find in the README as well, about the full demo and how it works. But yeah, I'll try to take a look into this. But yeah, that's pretty much like the workshop. If you have any questions, I'll be right over there. Feel free to reach out to me, and I'll showcase this to you once it's fixed. Thank you so much.
For everyone, let's All right, everyone. That's thank you, Anirudh. Let's give a round of big applause for Anirudh. Yeah, and Anirudh, we need to talk after this because I need to automate my job at ICP. It'll make my life easier. And man, like, yeah, it's fantastic this technology where it's heading. Thank you so much for your time.